Good morning, good afternoon, and good evening. This is Ira Fiusal from Group 3, and I'm going to tackle the first 4 pages of our PowerPoint. So our group is designated to discuss the topic about environmental chemistry, which is atmosphere. At the end of this module, the students shall be able to We have 3 learning objectives. First, describe the atmospheric reactions with the environment. B, explain greenhouse effect. And C, illustrate the depletion of ozone layer. So, before stepping into our first topic, which is the chemistry of the atmosphere, let's first review the 4 environmental segments of 4 environmental segments. First is the atmosphere. So the atmosphere is the protective blanket of gases, suspended liquids, and solids that entirely envelopes the Earth, sustains life on Earth, and saves it from the hostile environment of the outer space. So we are aware about the ozone layer, right? And it is part of the atmosphere. So the ozone layer sits in the stratosphere because there are five parts of the atmosphere. We have the stratosphere, we also have the lithosphere, the thermosphere, exosphere, and mesosphere. But that is not in order. So one thing that we need to remember about atmosphere is the ozone layer. So the ozone layer sits in the stratosphere. It is 15 to 30 kilometer above Earth's surface. So ano bang ginagawa ng ozone layer? So the function of the ozone layer is to absorb most harmful ultraviolet UVB radiation, protecting humans, animals, and plants. So yun yung ginagawa niya. And what is the cause of depletion? Or ano binag-harm sa ozone layer natin in our atmosphere? We have chemicals, especially yung pinaka-known, which is CFCs, or the chlorofluorocarbons, and other halons that breaks down our ozone molecules. And may mga health risks din kapag na-damage ang ating ozone layer. For example, it increased skin cancer, cataracts, and it can also weaken our immune system. And of course, kung merong mga health risk, meron din siyang mga environmental risk. Nadadamage niya yung mga crops, and most of all, ang ating ecosystem. So, that is atmosphere. It blankets or it is a protective blanket of gases. So always remember that atmosphere is the protective blanket of gases, that suspended liquids and solids that entirely envelopes the Earth. Okay, the atmosphere protects us from harmful risk that may occur to us. Next is number 2 is hydrosphere. So what is hydrosphere? Hydrosphere, it consists of all types of water resources such as oceans, seas, rivers, lakes, streams, reservoirs, polar ice caps, and water below the Earth's surface, which includes all surface and groundwater. So in simplest way to say it, hydrosphere, from the word hydro, which means water, it talks about the bodies of water, or all the types of water resources. So lahat ng nakikita nating water resources, dito fall sa may hydrosphere. Next is number 3, lithosphere. So lithosphere, it is the outer mantle or the soil of the solid earth consisting of minerals occurring in the earth's crust. So dito naman sa lithosphere, it talks about earth. Okay, the structure of the earth. Kung sa hydrosphere, it's about water. Dito naman is the structure of the earth. So, quick trivia lang pala, no? 71% of Earth's surface is covered by water. And 97% of Earth's water is hold ng ocean. So, ocean holds 97% of Earth's water. And only 3% yung fresh water. So, bakit ko ba ito pinopoint out sa hydrosphere? Essential kasi yung hydrosphere for regulating climate and supporting ecosystems. And also, it provides water and food, mainly. Next, going back to lithosphere. Lithosphere is, as mentioned, it is a solid outer layer of the earth, including the crust and upper mantle. So it contains soil, rocks, and minerals that form the foundation for agriculture and construction. So sa lithosphere, it is divided into tectonic plates. Okay? And sino nakaka-recall pa no mga na lesson before about tectonic plates? So tectonic plates, those are the massive slabs of Earth's lithosphere that float on the semi-fluid mantle beneath, and their movement shapes the planet by causing earthquakes, volcanic eruptions, and mountain formation. So, these are the rigid sections of the Earth's crust and upper mantle. So, ano naman nang naproprovide ng lithosphere? When we talk about lithosphere, it's all about the resources like metals, fossil fuels, and fertile land. And last but not the least, we have biosphere. From the word bio means life. Okay? So it is the realm of living organisms and their interactions with the atmosphere, hydrosphere, and lithosphere. So, to remember and to easily identify the meaning of biosphere is living organisms or our interaction with the hydrosphere, lithosphere, and the atmosphere. So that is the study of, or that is biosphere. From the word bio means life. So it's all about us living organisms and how we react, interact, and act upon atmosphere, hydrosphere, and lithosphere. So those are the 4 environmental segments. Number 1, we have atmosphere. Number 2, we have hydrosphere. And number 3, we have lithosphere. And number 4 is the biosphere. Now that we have accurately reviewed these 4 environmental segments, our group will focus about atmosphere. And the next presenter will have to elaborate the chemistry of the atmosphere. So that is all. Thank you. And if you have any inquiries about what I have discussed to you, you can just approach me on my socials, which is IRFA Usal. That's it. Thank you very much.
I am Lyra Venice. For this part, I am discussing about atmosphere and composition. The atmosphere is the layer of gases surrounding the Earth. It protects us from the harmful radiation and supports life. It is mainly composed of nitrogen, which is about 78%, and oxygen at 21%, which we need for breathing. The remaining 1% includes gases like carbon dioxide, argon, and water vapor. Even in small amounts, these gases help control Earth's temperature. Overall, the atmosphere plays a vital role in sustaining life on Earth. For the structure of the atmosphere is divided into 5 layers: the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Each layer has different characteristics depending on the altitude and temperature. These layers are important because they help regulate climate, protect the Earth, and allow satellites to function. I will explain each layer in the next slide. So this table shows the different layers of the atmosphere and their functions. The troposphere is the lowest layer where we live and where weather occurs. The stratosphere contains the ozone layer that protects us from UV rays. The mesosphere is where meteors burn up, while the thermosphere is a very hot layer where auroras happen and some satellites orbit. Lastly, the exosphere is the outermost layer that gradually transitions into space. This helps us better understand how each layer contributes to Earth's protection and environment.
Hello everyone, I'm Nikki Bale. For the next slide, I'll be discussing the structure of the atmosphere. As you can see in the diagram, the atmosphere is divided into different layers based on their temperature changes as altitude increases. These layers include the troposphere, stratosphere, mesosphere, and thermosphere. So why does air pressure decreases as we increase altitude? It is because the pressure of the air can be related to the weight of the air in a given place. When we raise altitude through the atmosphere, there is some air underneath us and some air above us. Yet there is still less air above us than there was at a lower altitude. Second, why does the air temperature is highest near the surface and decreases as altitude increases? It is because variation in the properties of air reach outward from the center of the Earth. The sun heats the Earth's atmosphere, and a part of this heat is heated by the air near the surface. The hot air is either diffused or convected into the atmosphere. There's even less air to breathe. Now let's move on to Earth's radiation and energy balance. The Earth receives solar energy in the form of short-wave radiation and consumes about 70% of the sun. Although the Earth constantly receives solar energy or radiation, it will not begin to heat up. The Earth releases the remaining 30% of solar radiation in the form of long-wave radiation into space, which allows the Earth to cool down. The proportion of solar radiation that is absorbed and distributed out into space is also known as albedo. The sum of solar energy per unit time flowing through the unit area at right angles to the path of the solar beam measured just outside the Earth's atmosphere is known as the solar flux, also known as the solar constant. The solar radiation hitting the upper Earth's atmosphere is roughly 1,340 watts per second.
Good day everyone, I'm Ralston James Emerden, and today we will discuss the greenhouse effect and the role of greenhouse gases in Earth's atmosphere. The so-called greenhouse effect explains the absorption of heat above Earth's surface by atmospheric gases, in particular carbon dioxide. The glass roof of the greenhouse transmits visible sunlight and collects some of the outgoing infrared or IR radiation trapping the heat. As a result, heat is retained, making the environment warmer. Carbon dioxide behaves much like a glass cover, except that the rise of temperature in the greenhouse is mostly due to the reduced passage of air within. Calculations indicate that if the atmosphere did not contain carbon dioxide, the Earth would be about 30 degrees Celsius cooler. In fact, without CO2, the Earth would be as cold as the Moon. Now let's talk about where carbon dioxide goes. The main sinks of CO2 are first, the ocean. They absorb carbon dioxide and convert it into carbonates. Parang inaabsorb lang ng ocean yung mga CO2 from the atmosphere. So second is biomass or living green plants. Through photosynthesis, ginagamit nila yung CO2. Pero here's the problem. These sinks can only handle about 50% of the expected increase in CO2. So ibig sabihin, hindi nila kayang i-balance lahat, kaya tumataas pa rin yung CO2 sa atmosphere. Now let us look at the different greenhouse gases and their sources. The biggest contributor is carbon dioxide, which makes up 49%. Galing ito mainly sa mga fossil fuel combustion, deforestation, and even respiration. Next is methane at 18%. Makikita ito sa mga wetlands, marshy areas, and also from decomposition of organic waste. And kasama rin dito ang mga forest fires. Then we have CFCs or chlorofluorocarbons, contributing about 17%. Usually galing ito sa mga refrigerants, aerosol sprays, and foam production. Then we have nitrous oxide, which contributes about 6%, coming from soils, fertilizers, fossil fuel combustion, and biomass burning. And we have ozone, which contributes about 8% and is formed through photochemical reaction in the stratosphere. And lastly, we have water vapor, which contributes about 2% and comes from vaporization processes. So kung mapapansin nyo, a lot of these gases come from both natural processes and human activities. Kaya malaking factor talaga ang mga ginagawa natin. So overall, with rapid manufacturing and technological developments, tumataas ang production ng greenhouse gases at an unprecedented rate. And because of this, nagkakaroon ito ng detrimental impact sa ating global environment. So hindi lang siya basta concept. This is something that actually affects our planet today. And that's the end of our discussion about greenhouse gases in the atmosphere. Thank you for listening.
Oh, hi guys! So, ang sunod naman is ang ozone layer. So, pag-usapan natin ang isa sa pinaka-importanting shield sa ating mundo, ang ozone layer. So, ano nga ba ito? Ozone is concentrated in the stratosphere at various heights from 16 to 40 kilometers at different latitudes. This layer of atmosphere enveloped by ozone is known as ozone layer. It is also known as ozonosphere or ozone umbrella. The thickness of ozone layer is measured in Dobson units. 1 Dobson units is equal to 0.01 mm of decompressed gas at 0 degrees Celsius and 760 mm Hg pressure. So, ang una natin is ang formation of ozone. It is formed naturally in the stratosphere by the action of ultraviolet radiation, where M is a third body which absorbs the excess energy liberated by the reaction and thereby stabilize the ozone molecule. B. Advantage of ozone layer. It acts as protective shield as is absorbed by the UV radiation responsible for DNA mutation and skin cancer. The UV radiation may also cause global warming, faster degradation of plastics, fabrics, and etc. C. Depletion of ozone layer. The three main reasons where human activity has influenced the ozone layers are the following. First is direct emission of NOx by supersonic transport. They just fly over the tropopause to maintain their speed because of low resistance. Second is use of chlorofluorocarbons. Third is increased use of nitrogenous fertilizers.
I am Shelshonfi Agaceta, and I will be explaining the mechanism of ozone depletion and the global action against ozone depletion. Mechanism of ozone depletion. First, nitric oxide converts ozone into oxygen gas and nitrogen dioxide. Nitric oxide acts as the primary initiator in the chemical destruction of the ozone layer. Nitric oxide is a highly reactive molecule that seeks to stabilize itself by stripping an oxygen atom away from ozone, effectively breaking the ozone molecule apart. Second, nitrogen dioxide form reacts with nascent oxygen. The nitrogen dioxide produced in the first step continues to react with other atmospheric components. The stratosphere contains nascent oxygen or a single oxygen atom. Nitrogen dioxide has a high affinity for these single atoms, leading to a secondary reaction. The reaction is represented as nitrogen dioxide plus nascent oxygen produces nitric oxide plus diatomic oxygen. In this process, the nitrogen dioxide gives up an oxygen atom to the nascent oxygen atom. This step is significant because it consumes the oxygen atoms that are needed to naturally build new ozone. Third, nitric oxide is regenerated and the depletion continues. The chemical process functions as the catalytic cycle, meaning the destroyer is never permanently used up. Because nitric oxide as a byproduct, the original molecule is born again and is free to attack another ozone molecule. As shown in the diagram, the arrows form a circle. One molecule of nitric oxide can repeat this two-step process thousands of times in a continuous chain reaction. The regenerative nature of this cycle explains why even small amounts of nitrogen oxide from supersonic transport can cause massive long-term depletion. Next is the global action against ozone depletion. The first global action is the Vienna Convention. The convention laid a framework for global cooperation on arresting ozone depletion. The Vienna Convention served as the global foundation for atmospheric protection. Before specific laws could be passed, the international community needed a formal agreement to cooperate at scientific research and data sharing. In 1985, 20 nations signed this framework to standardize how they measured ozone thickness in Dobson units. It was the first time the world united to acknowledge that human activity was having a detrimental impact on the global environment. Second global action is the Montreal Protocol in 1987. The Montreal Protocol is the binding international treaty that mandated the phase-out of ozone-depleting substances. Unlike the Vienna Convention, which was just a framework, the Montreal Protocol set strict legal deadlines to stop using chlorofluorocarbons and transition to hydrofluorocarbons. The treaty has been so effective that by 2008, efficient equivalent fluorine levels in the atmosphere had declined by approximately 10%. With 197 current members, it is considered the most successful environmental agreement in history, putting the ozone layer on a path to recovery.
Hi everyone, I'm John Mark Lawrence E. Farnacio. For the next slide, I'll be discussing the topic acid rain. So first, i-define muna natin kung ano nga bang acid rain at paano nakakapekto sa environment. So acid rain nga pala guys is any form to ng precipitation rain. So it can be either snow, fog, or dust. Basta mataas yung levels ng nitric tsaka sulfuric acid niya, matatawag natin tong acid rain. So acid rain causes severe damage to stone monuments, crops, and marine life, earning the nickname stone leprosy for its destructive effect on stone structures. So, konting kaalaman kung bakit tinawag na stone leprosy yung acid rain guys. Kung mapapansin niyo yung mga establishments na parang powdery na yung surface niya, na para, mako-compare natin yun sa skin disease na leprosy guys. Kaya tinawag siyang stone leprosy yung acid rain. While carbon dioxide alone cannot lower rainwater pH below 5.5, sulfur dioxide and nitrogen oxides from vehicle emissions are the main contributors to high acidity. Sulfur dioxide reacts with water to form sulfuric acid, intensifying the problem. So, ito na yung sinasabi ko guys, na kapag mataas yung nitric tsaka sulfuric acid niya, yung isang rain, nagiging acid rain to. Yung mga major sources nga pala ng sulfur dioxide, nag-include to ng volcanic eruptions, naturally occurring sulfur in minerals, and human activities such as smelting or roasting metal sulfide ores, which then release sulfur dioxide into the atmosphere. So, for better visualization guys, tignan natin yung diagram sa next slide. So, kung makikita natin sa left corner, may mga man-made sources dito, like factories, power plants. So, hindi exception yung natural sources natin dito. Like volcanoes, ganun, tsaka mga trees. So, kung makikita natin dito sa left corner tsaka middle, yung may mga nire-release itong sulfur dioxides tsaka nitrogen oxides, which then travels sa air pataas. So, ito yung movement ng pollutants, which then mapupunta siya sa atmosphere. Dito na nagtitipon-tipon yung mga gaseous pollutants natin. So, kapag like uulan na, like ito yung wet deposition natin. Ito yung usually na tinitik natin as acid rain. Yung pollutants na nagmix sa water, sa ulap, dito na nagfo-fall yung as acidic rain o snow or fog. So makita niyo yung arrow dito nagpo-point na pababa sa forest tsaka lakes. So yung dry deposition naman guys is ito naman hindi siya minsan it doesn't even need to rain. So yung acidic particles at saka gases nito can simply stick to the ground guys, buildings and trees during dry weather. So, yun lang guys for acid rain. Thank you.
So, good morning, good afternoon, and good evening everyone. I am Mark Rodney San Pedro and I will be explaining photochemical smog. First, identify muna natin kung anong photochemical smog. The term smog was coined to describe the mixture of smoke and fog that engulfed London in the 1950s. Today, though we are more familiar with the photochemical smog produced by the reaction of vehicle emissions in the presence of sunlight or araw. So, ang photochemical smog daw ay napoproduce galing sa reaction ng usok and sa araw. Kaya mostly nangyayari ang photochemical smog sa urban area and cities kasi mas maraming sakyan at mas mainit ang panahon sa cities. For example na lang ng mga urban area and cities is Manila and Tuguegarao. Nangyari din siya mostly kapag traffic and summer season. Automotive exhaust consists primarily of nitrate oxide, carbon monoxide, and various unburned hydrocarbons. So, ang examples ng mga unburned hydrocarbons natin ay mga gasolina. These gases are called major pollutants because they set in motion a series of photochemical reactions that create secondary pollutants. The secondary pollutants, mainly nitrogen dioxide and ozone, are responsible for the build-up of smog. So itong mga to guys is mga key components or elements kaya nabibuild up ang photochemical smog. Next, mechanism of photochemical smog or how photochemical smog is formed. So kapag nagbuga ng usok ang mga sasakyan natin or mga truck, maglalabas yun ng mga nitrate oxide which is mag-react kapag nainitan. And kapag nag-react yun, magpaproduce sila ng peroxide radical. Then pag nag-build up yun, mag-react ulit siya sa nitrogen dioxide. Kaya nag-produce ang PAN or peroxyacetyl nitrate, which is may side effect siya sa atin. Kaya kapag mainit ng panahon or traffic, nakakaranas tayo ng eye irritation, chronic disease of lungs and heart, cracking of rubber, and plant damage. This interaction sometimes lets the environment seem hazy. As the mechanism of photochemical smog formation has been better known, significant attempts has been made to reduce the buildup of primary contaminants. Most cars are now fitted with catalytic converters engineered with oxidized carbon monoxide and unburned hydrocarbons to carbon dioxide and H2O or water, and to reduce nitrate oxide and nitrogen dioxide to nitrogen and oxygen. Hydrocarbon oxidation produces various chemical intermediates such as alcohols and carboxylic acids, which are less fragile than the hydrocarbons themselves. These liquids are gradually reduced into tiny droplets of liquids. The dispersion of these droplets in the air is called aerosols. Disperses the sunlight and decrease visibility. So, itong mga to guys, example ng mga ginawa ng ating government or car companies para ma-reduce na mangyari ang photochemical smog. And that's all. Thank you for listening everyone. And don't forget to subscribe.